Welcome to Unlocking Java's Codemotion session. My name is Mihaela. I'm from Romania. I'm a software architect at Systematic. This represents a Danish company specialized in building software for critical domains, hence the part with the defense domain. Those critical domains that I was mentioning about are like building software for the military guys, for the ones working in healthcare or libraries and learnings or national security risk and domains similar like that. I work for the Defense Department, so I'm building software for them. I'm also a teacher at the Faculty of Cybernetics and Informatics in Bucharest in Romania. But even though I'm here to talk about Java, I'm teaching C and C++ at the university. I teach my students the basic of algorithms, like, I don't know, dice, track, Ruskell, prim, and so many algorithms that are the basis, the foundations for programming. But as mentioned today, I'm here to actually ask you to actively participate in my session because this is meant to be a blend of both exploration and active participation. So I will kindly invite you to have your phones nearby. I will do the same because I will trigger the quiz. It is a quiz, but it's mostly interactive. So we will have a bunch of exercises related to different subdomains from Java. I will show them shortly what those are. And for each of those exercises that are either specific to what specific pieces of code do, so what's the output when we run a specific piece of code, or how we can improve a specific piece of code. But before that, think of Java programming like navigating through a vast, intricate maze, hence the picture on my slide and the title of my presentation. And in this maze, we have both challenges and hidden gems in the world of Java. Today, we are going to explore just a very, very small part of it. I only have like 15, 16 exercises. Hopefully, we can finish all of them. So I do hope that you had a very enjoyable lunch and you had some time to relax because we are about to kick off this exercises section. And in terms of agenda, I also have one item. I only have one item over here, that's exercises. But here are some of the examples that we are going to address. So we'll showcase different examples for working with collections, with streams. I have a couple of exercises with streams, but also records, concurrency, and many others. I try to also focus on the newer functionalities introduced in later versions of Java, like 15, 17, 21, and so on. So this is the slide where you will find the QR code. Please scan that one. The quiz won't appear immediately because I need to enable it. If for some reasons the QR code doesn't work, even though I tested it right before the session, you also have the possibility of just enter as in url.slido.com and that meeting number 1695628. And I will leave this one until I finish speaking and we will move to the exercises. So the format will be consistent to have a smooth experience. We will have an exercise. We will look at a specific piece of code. There are only two questions, either what that specific code does or how we can improve it. Then we will have a couple of answers. There are 4 options. Only one is correct. And as a small disclaimer for those exercises regarding optimizations in terms of code, those I can argue that they are subjective. So the answers are from my point of view and I will explain them. Obviously, that's not the only solution to improve that piece of code. There can be plenty more, but I only selected one that I thought of on those situations. So I hope everyone scanned the QR code. And let's start with a warming exercise. I hope you're ready. And I'll also enable the quiz now, so something should appear for you, and you can join now. And while you do, I'll provide you some examples of what we have in this exercise. So most of them will be something like that. A specific piece of code, those options to select one of them, and afterwards at the end we will discuss. Based on your answers, I will provide details why one of them was the correct one, and based on the answers, I'll also pick the others that were selected and not being correct and tell you why they weren't correct. And this is just a warming up exercise, so I expect something simple, quick, and everyone to provide the correct answer. And let's go through it. So what we have here, we have static variable initialization. where I will tell you a little bit of insight. The order of the initialization matters because sometimes it can lead to unexpected results. What do you think the displayed output would be in this specific case? So we have there a value initialized at the beginning with a value of 10 in a static block. Then we have another static block where we set a value of 20. When we have that simple print line in the main method, what do you think we will get? And pay attention that now you can submit your answers. So let's see. How static initialization order do you think that it affects the final value of that static variable? And you have less than 20 seconds. And so far, all the options are being selected. I want to repeat again that only one is correct. Okay, and we are in between B and C. So either 20, either a compilation error. Let's see till the end. All right, ready? The right answer, you will see it also on your phones, but also here, is B. So those of you that selected B, and almost half of you did that, well done. That was the correct answer. It won't get into a compilation error because this was the second one selected. It actually works fine. If you want at the end, I guess I can open my idea and look at DD and see that it works correctly. But why it works? So what we have there once again. The static blocks are being executed in the order they appear. So first of all, we have that block where we set the value of 10. That is being initialized. But afterwards, that variable declarations overrides earlier assignments. So when we come with the second block, when we set a value of 20, it simply overrides the previous one. It doesn't throw a compilation error or something else. So this is the correct answer, which is 20. And this exercise was just meant to show that the final static initialization takes precedence in cases like that. Okay, hope you warmed up a bit with this sort of format of exercises, because we are about to move to the second exercise. And let's say that this is the second warming exercise. We have an example of working with streams. And this one starts from a simple list of strings and performs some operations based on a stream obtained from that list. And that list is simply a list of fruits. I didn't have done any other idea, so I put some words over there. So this example partitions a list of strings based on a condition, but there is a twist over there with the method that I called it check vowel. What do you think the displayed output would be? What do you think that twist that I'm mentioning about is it? And let's see what do you think. I have enabled the possibility for you to submit the answer. So we have a list of strings, and we perform some operations based on it. What do you think we will get? So far we are in between A, B, and D. Nobody selected C. And less than 10 seconds. So far D is winning, A is on the second place. And time's almost up. And let's see the result. So the majority of you answered correctly. The right answer is D. And let's look why. So this example uses that method that you see over there, partitioning by. Almost everyone seems to be familiar with it, at least those that have selected option D. It has been in the Stream API for a very long time, and if I remember correctly, even since Java 8. So there's been a couple of years. And we have a custom method over there that determines if the string starts with a vowel. So maybe this caused the confusion. That's where the twist is, the method that checks for the vowels, and that's because it uses regular expression. And the correct output shows words that start with vowels and those without. Hence, the correct result is option D. All right, let's continue. And now it's time for a first code optimization challenge. Let's start from what this exercise is meant to do. First of all, we have a list of strings, as the example over there. And the purpose, as you can see, will be to group words by their first letter. How would you change these few lines of code to improve it? And among the answers that we have there would be option A, perhaps to replace the traditional for loop with a parallel stream, in case it provides us a better performance. Option B, to use a custom collector instead of the grouping by collector for more flexibility, because I have used that one. Option C, to encapsulate the logic within a lambda expression to promote functional programming. Or D, no changes. The code is already optimal. So let's see out of these 4 options, and I did mention there are plenty more options to improve this specific code, but I only selected a few, and one of them is more accurate and correct than the others. And let's see, what do you think? You can submit your answers now. So how, or if you want to improve something, how would you do that? Out of those 4 options. Use parallel streams, use custom collectors, lambda expressions, or nothing. And I think the battle is for now between A and C, and a few selected B. Let's see till the end. You still have time. A few more seconds. Right, and most of you answered correctly, but there were quite a lot of you that selected option C. So let's go a bit through the code. Let's start from the beginning. So in this code, we generate 10,000 random words. This is the first line of code. Afterwards, we group them by their first letter using a traditional for loop and a hash map. While this works fine, option A suggests a key optimization, replacing for loop with a parallel stream. And this can improve the performance because it processes those elements concurrently across multiple threads, which is ideal for working with large data sets. You may argue that 10,000 might not be such a huge, large data set, but it is. If I would have used 2-3 words, for example, over there, it wouldn't have an impact. But for 10,000 and upper, that's the best option. Now, among the other options that you have selected, I'm not going to talk about option D. That's definitely not something to select. To claim that the code is optimal, no way. I just put it there to trick you. But let's look at option B. It mentions to using a custom collector. Well, this offers more flexibility indeed, but it adds unnecessary complexity without any clear benefit. So I wouldn't go with this approach. And option C, to encapsulate the logic in a lambda expression, which seems to also be selected by most of you. It leans towards functional style, but doesn't directly enhance the performance. So I wouldn't go with this one either. Okay, let's see how the code will look like with using parallel streams. So I also refactored that specific line with this one. I just use parallel stream instead of stream. That's simple. And in this modified version, we are using the parallel stream just to utilize the multiple threads functionality that they provide. Let's move to something else. I did mention that I have several topics from Java, and I didn't group them so that you won't get bored of working with streams and so on. So this time, we are going to look at an example for type erasure and generic constraints. And we have here, if we look from your left to right, we have a box class, which is a generic class with a type T parameter and methods to set and get the content of that box. Afterwards, in the main method, we are setting the context first to hello, so to a string, and afterwards we have a row box object which is created and is being assigned to that string box. What do you think the display output would be in this scenario? If I am to run this piece of code, what do you think it will get printed? Among the answers, we have either a hello, so this was the first initialization. We have 1, 2, 3. This is the second initialization for that row box object. Option C mentions that we'll get an exception at setting content for the row box to 123 as a value. And option D mentions that we will actually get an exception at getting content for the string box. So out of these 4 options, what do you think the correct one is? And you can submit your response now. So let's see. Oh, that was fast. We are already in between B and C. These 2 are winning. And we have less than 20 seconds already for those of you that haven't submitted a response yet. Option C seems to be winning so far. Some of you also selected A and D. And time's up. Let's see which was the correct answer. If those that selected C were right, no. Most of you selected C, but that's not where the problem is. So let's look why. So everyone that selected either C or D, you're right. We will get an exception. So we won't get the options were hello and 123. We won't get any of those. We will get an exception. And let's see why. Type erasure in Java leads to row types that bypass compile time type checking. This is how it works. So, assigning a row type to a generic variable allows setting content of different types. So when we try first to set to a string, then to an integer, nobody complains about anything at that moment. But when row box set content is being triggered with the 123 value, there is no compile time. But when we try to retrieve the content for the string box, we'll have a class cast exception because it was expecting a string but receives an integer. So this is where the exception appears, not on the set content for the 123. Nothing happens there. It works, it allows us to continue. We will get the error when we try to get the content, and that's because we will have a class cast exception. We were expecting a string, but we get an integer. Okay, let's move to something playful. Let's play a bit with string concatenation. And we have here just one line of code. Let's say that we have one line of code. We have a result, which is a string, and is being initialized like that. The result is +1, +2 multiplied by 3. If we were to run this simple line of string of code and we print the result, what do you think we will get? The result is obviously common. I didn't bother to try to trick you over there, but what we will get afterwards, it is a 7, a 16, a 9, or 1 to 3. These are the options. Let's, I think I have forgot to reveal the answer for the next one, sorry. Now let's try to see what do you think for this exercise. So what do you think the right answer is? Already in between A and B? Let's wait till the end. For this exercise, think of the operator precedence, because it is quite critical to understand it to avoid unexpected results when we try something like this. So let's see. A few more seconds. All of them were selected, but most of you are in between A and B. And let's see who's right. And most of you selected B, which is the correct answer. And let's explain a bit why. Let's have a code breakdown on that small piece of code. We know that in Java, the plus operator works for both the addition in terms of numbers, but also for concatenation in case of strings. But when the plus operator is being used against a string, it converts the other operands also to string and concatenates them. So if we were to check that expression, first of all, we have the result is +1, +2 multiplied by 3. It is evaluated from left to right, as we know it happens, following the operator precedence rules. This is why I mentioned earlier to think about this. The result is a string. So when we have that plus, afterwards it converts what follows afterwards to a string. 1 is an integer. But 2 multiplied by 3, this takes precedence. This is what happens first. And then we have a string plus a string plus a string, which is the result is 1, 6. And this is how we get to the B answer, which was correct. Good. Now that we finished this one, let's try another exercise with streams. And in this specific case, we are applying mapping to transform a nested collection. But there I have a subtle condition within that mapping logic. What do you think the display output would be in this case? And I will let you take a second look at the code. And also I have triggered the possibility for you to submit the answer that you think it is correct. So let's see. 100% C so far. B also has some votes. And you have just 1 more second. But I guess this was too easy because most of you answered correctly. So I don't think we will go that much into the details. That subtle condition that I was trying to mention about is the use of flat map, which is used to flatten a nested collection and applies the mapping to transform each element to uppercase. So this was quite something simple. Then let's move to something a little bit more difficult, and that's Java concurrency. Once again, we have here, let's say, a Java puzzle, which uses concurrency and a specific map, hash map. We have that concurrent hash map and 2 threads that are attempting to update that hash map concurrently. Each thread, as you can see there, is incrementing the value associated with every key in the map from 0 to 999. And it does that by incrementing the value by 1. That is the second parameter from there. And it uses the merge function. Your task now is to determine what do you think the output would be for this program. What do you think the resulting sum of all those values will be? And among the options we have there option A, 1,000, 2,000, 10,000 or 20,000. So one of these 4 is correct. And let's see which one. And please submit your answers. And afterwards we will go through the options. So what's the resulting sum of all those values after both threads finish their execution? Obviously. So let's see. All the answers are being selected at this moment. We don't have a clear winner, maybe in between A and B. A few more seconds. And the right answer is B. So most of you answered correctly. Most of you selected any other options from that list. Maybe I should have added even more options over there. So here we should reflect carefully on the atomicity for the merge operation. That's the tricky part over there. Because merge takes 3 arguments. The first argument is the key. Then we have the new value. Then we have the function to apply if the key already exists. These are the 3 arguments. So we have the key, the value, and the function to apply if we have that key already over there. And then, what do we have in the code? We are using integer sum. So we are, if the key already exists, we are trying to sum the existing value to that value provided as parameter. And after submitting both tasks to the executor service, we shut down that service, wait for both of them to complete successfully, and finally, we'll print the sum of all values, which will be 2,000. This was the correct answer. So we multiply 1 plus 1, meaning 2, and we get at the end 2,000, as we repeat this for 2 threads. Right. And now that we have seen this example, Let's see what do you think about the second one. We will stay in the same area a little bit more. And we are also in the middle of the exercises, so we are half of them already completed. And here we have an atomic variable this time, which we know that offers thread-safe operations for concurrent programming. But in these examples, we are testing, let's say, the understanding of how atomic integer and concurrent updates work. And let's see what do you think the correct answer will be in this case. So first of all, we have an initial value for that atomic integer that we are using of 0. Then we have two threads where we are using increment and get. We are starting them, joining them, and getting the final count at the end. What's the right answer? Let's see what do you think. You can submit the answers now. And you can choose between 2, 1, 0, or an error. Maybe this code won't actually work. You can use the same analogy that we have seen in the previous example. They're pretty much alike. And you have a few more seconds. And time's up. I'll reveal the correct answer, and that is A. And indeed, most of you selected the right one, but I see that some of you also selected 1, 0, and an error. Well, I did mention that atomic integer allows thread-safe operations, and that method, increment and get, that I have used over there, is one of them. So it works in this specific case. We don't get an error. Afterwards, we have those two threads that are concurrently incrementing the count. So then in the main thread, what we have? We have those threads that waits for both of them to complete before printing the final count. And because both of them will execute correctly, it will increment up to 2. That's it. We will have 2 threads. And that's the correct answer. All right. Let's move to a newer functionality, a bit newer. And that's sealed classes. Have you already started working with them in production out of curiosity? Nobody? But, okay, some of you. Good, nice. So let's look at this code, and this is a bit huge, so I'll mostly let you look at it more than on the others. In this specific Java code snippet, I try to demonstrate some advanced usage of sealed classes with nested sealed classes. And we have over there the class shape, which is declared as sealed, and it permits circle and rectangle. Then we have an abstract method declined as an area. Then we have the nested class circle, which extends shape, which implements drawable. That's an interface that you can see on the right side. Then we have a rectangle class that extends only shape. That interface is also declared as sealed. It permits circle and rectangle. And in the main method, first of all, we are declaring an object of type circle. It's called shape as the object name. Then we are checking if it is an instance of that drawable interface, in which case we call the draw method, or otherwise it displays that the shape is not drawable. What do you think we will get if we were to run this code? As an option, or as options, we have that we get a compilation error. We have as B that shape is not drawable, so the else statement over there. Perhaps we get a runtime error or nothing. Nothing gets displayed. This means that neither the if, neither the else statements will actually be triggered over there. So what do you think we will get? And hopefully you had plenty of time to look at the code. So let's see what do you think. I have now triggered the possibility for you to submit your answers. And also you have more time on this question. You have almost 50 seconds now. 40, sorry. So let's see what happens over there. We will get a compilation, we will get a runtime error, nothing, or shape is not drawable. less than 20 seconds. Okay, answers are still coming. So final seconds. And let's see, let's look a bit at what you have selected over there, all of them. Let's say in the top it will be a compilation, or that message that the shape is not drawable, or a runtime. These are the top three. No, sorry, C and D are equally. Let's reveal the answer. And those of you that selected the compilation error, you are totally right. And let's see why. So, looking at the code again, and I will look at mine here as I see it better. Even though shape circle implements drawable, it never actually provides an implementation for the draw method. And I believe you agree with me. I haven't added that implementation over there. So Java does not allow instantiation of a class that declares and implements that interface, but does not implement all its methods. So the problem was something simple like that. Unless it was an exception, unless the class is declared abstract. So if circle would have been abstract, then we wouldn't have received a compilation error, but it isn't. And because we don't declare that draw method, we don't implement it, we will get a compilation error. And the other answers, if we were to look at it, for example, option B, that you also have selected, that shape is not drawable, that's incorrect. Would be possible only if the code compiled in the first place, and it would have reached the else statement. Runtime error, no, it is a compile time issue this time. And no output, no, it doesn't compile, so nothing will be displayed. Cool. Let's move to another functionality introduced in later versions of Java, and that's working with records this time. And here, what do we have? We have 2 points objects, and we want to simply compare them by 2 options. One of them to use the equals method, and the other one is to use the equality operator. So if we try to compare those 2 points objects, and you can see there that they have the same values for the coordinates, 3 and 4, both of them, so no problems in terms of the values. But what we will get if we were to compare them by a situation. And let's see, what do you think? You can submit your answers. I guess we already have a winner, but let's wait till the end, as there are still votes coming in. So what we will get if we compare those 2 objects? Time's almost up. If you want to still submit your answers, you can do it. And let's see if most of you were right with the C answer. And yes, you were. So, records were introduced in as a preview mode actually in Java 14, but they were finalized or introduced as a standard functionality in Java 16. They are used to create immutable data carrier classes. We know that there are some methods that are being automatically triggered behind the scene when we simply declare a record like I have done in this example, just point at those 2 properties that we have. And the equals method is auto-generated. So when we try to compare those 2, point 1 and point 2, this will lead to true. On the other side, when we use the equality operator, that compares object references, and obviously they are different, so it results in a false, making it making C option the correct option to select over here. Let's move to the next exercise. We have just a couple more. And here we have something different than what we have seen so far. In this example, I have tried to showcase the use of list of, where I define a list of strings and I simply try to add another one. So we have a list of 1, 2, and 3, and I try to add a 4 string a word over there. What will happen when we run this code? Among the options are A, unsupported operation exception. Option B, we will get a 4. Option C, we will get an error. And option D, none of the above. So maybe something will happen, but none of this. You can now submit your answer. And let's see what do you think. What will happen if we run these 2 lines of codes embedded in a main method, along with all the other boilerplate sequences? All right, we are in between A and D. So either that exception that I mentioned over there or none of them. Okay, a few more seconds. And so far option D is winning. But the correct answer was option A. Sorry for that. Let's look at the code from the very beginning. So we have the list of method that creates an immutable list, meaning that it cannot be modified after creation. So at least we agree with this. So option B, we can remove it from now. We can't get a 4. Not to mention that I haven't printed anything, so we couldn't have gotten option B anyway. A simple error, no. When we try to add an element, another element, that 4 elements, to an immutable list, we will get that unsupported operation exception. So this is what happens when we try to alter an immutable list. So the answer was not none of the above because A is being triggered. And I believe this exercise just emphasizes the importance of knowing how to work with the immutable classes, what list of creates, and what is the exception that is being thrown when we try to add something in there. Unmodifiable, yes, correct, sorry. Thank you. All right, let's move to the next exercise. Also with streams, and this time I have used 2 methods over there for the stream API. I'm curious if you work with them, skip and limit. Do you know them? Only a few? All right, let's see if you can at least guess what they do, and afterwards I will tell them I will tell you what they do. So this code snippet creates a stream from a list of integers and uses skip to skip the first 3 elements. That is what we have there. Then we have limit to restrict the stream. And we have there an output being collected at the end. What do you think the answer is? I already provided you some guidance of what the methods do over there. So we have skip and limit. First with a value of 3, second with a value of 4. And you can submit your answer. And let's see. And I think we have some air conditioning coming in, so we can enjoy it. And returning to my exercise, let's see what do you think over there. We have only 5 seconds left. And most of you selected B. And you're totally right. I already provided you a few guidance of what those methods do. So skip 3 simply removes the first 3 elements from our list, leaving us with the value starting with 4 to the end. Then we have limit with an argument of 4, which restricts the resource to the next 4 elements, leaving us with 4, 5, 6, 7. So this was the right answer. All right, let's continue as we have just a few more minutes left. And this time we have once again an optimization challenge with concurrency and completable futures this time. Once again, I will leave you more time for this because it's a lot of code to process. My question for you would be, what would you change to ensure that the stream processing remains parallel and returns the same result? So we don't want to change the functionality of this exercise. First of all, we are using those 3 completable futures, future 1, 2, and 3. Then we are using then combine for them. And at the end, For the final result that I have added over there, I use the join method, and I simply try to print the final result. Now, those task 1, 2, and 3, simply returns the value 1, 2, and 3. So if we want to keep the functionality, but just improve the specific code, what would you choose out of those 4 options? Among the available options, first of all, to replace then combine with all of. Secondly, to add an explicit executor to supply async. Third option, to use then compose instead of then combine. Or perhaps D, to change that join to a get, when we have over here the final result is result.join. So out of these 4 options, how do you think we can improve this specific piece of code? And you can submit your answer. Let's see what do you think. So far we are in between A and D. And less than 20 seconds. So if you want to submit, you have selected all options. Most of you either A or D. And time's up. So let's see what was the right answer. And the right answer was A. Most of you selected it right, but there were a lot of you that selected option D, and also a couple of you that selected B and C. I would say that completable future all of is the best choice over here. And why? Because it waits for all the futures to complete, first of all, allowing, let's say, true parallel execution, which is more performant than simply chaining then combine, which handles only 2 futures at a time. So this is why option A is the best one to choose out of these ones. For the last one, I'll talk about this one because this is the highly selected in terms of, let's say, second place. Replacing join with get will still work. They pretty much do the same, if I can say that, but join is preferred for the completable future because it throws unchecked exception. So I wouldn't change that one from this point of view. So I would argue that option A is the best that we can choose out of these 4 options. But obviously, we can think of other options. Let's see how the code would have looked like with the all of. So it's just changing at the beginning, 1 line of code. Nothing special over here. So let's move to the next exercise. And that's dealing with lambda expressions. And yes, there is a huge method over there with the filter words. So let's examine what I have written over here at the beginning. We have some lambda expression that demonstrates how to filter a list of words using multiple predicates. Let me look at the code, what I have written over here. So, first of all, we need to identify what can be improved. That's the goal. And in this code, first of all, we define a list of words. We create 2 predicates, one to check if the word length is greater than 5, and another one to check if the word starts with a value of A. Then we filter the words using that filter words method, which accepts a list of words and an array of predicates. It works. It displays the right answer. But that filter words method checks each word against all predicates and adds to the result list if it matches all of them. So how would we improve this specific piece of code? As options: A, to refactor filter words method to use stream API and combine predicates using AND, or B, inline predicate combination in main. Option C, to use filter words without any modification, so the code is optimal, leave it like that. Or D, replace predicate with custom functional interfaces for better performance. So let's see, and you can now submit your answer. Let's see what do you select out of these 4 options. And this is also our last exercise because we are running out of time. And you have less than 50 seconds. So far, A seems to be winning, but also B, D, and C are being selected in this order. And not to wait too long, the right answer is A. Refactoring filter words is definitely a must-do. I will show you how I refactor it. And we need to use the stream API and combine those predicates using the AND method because it results in a more concise and readable code, and it will look something like this. So the entire solution for this exercise resumes to something like this. I think it looks way better than what we have just seen. And because time's up, we won't be doing the next exercises, but at least let me show you the leaderboard. And you can see now, just remove, you'll see that the maximum is 16, just remove 2 because we didn't manage to finish those two items. So we have 14 as a maximum, not 16. I would like to thank you all for your participation. This session was meant for you to participate, so once again, thank you for being active on this. I hope you had some fun with these exercises and at least learn something new out of these 14 exercises that we have managed to do. And I would say that enjoy the rest of the conference. Thank you very much for your presence, and have a good day ahead.